As the name says, sliding bridge project is unique to Texas. First one done here. It's been done in several other states. The original design was more conventional, but used precast caps. The contractor actually came to us and said, and asked if they could do this method because they've been doing it in other states. And we sort of talked about it and said, yeah, sounds cool. Your cost, of course, but let's see if we can make it happen. They brought their own engineer and they redesigned the plans, and I think it turned out to be a really successful project. Real quick, as I was going through this morning, I realized I didn't put a map to sort of locate everybody, orientate you in here, but in San Antonio, Texas, Fredericksburg Road runs basically north to south, parallel to I-10. Medical Drive runs basically east to west. It's a primary route from 10 into the center of the medical district, especially for emergency services things. The original intersection was at grade with traffic lights, etc. Can you imagine an ambulance trying to get through and things? So the impetus for the project was to grade separate that intersection. So primarily for emergency services. So they don't have to stop that intersection, they come straight through and get to the hospitals and the emergency rooms. You know, when you're in trouble, when you're sitting in your office, doing minding your own business, and the boss comes in and lets you know that she's supposed to coordinate one of the breakout session short course. And she's smiling. And she asks, can you present? And I couldn't find a way out, so I did what any normal, sane professional would do. I immediately panicked. Okay. Next several sections, I engaged in some mental whining. Why me? What did I do now? That last change order dollar amount was large, but it was justified, I think. David? Funds were available. I had a spreadsheet. Then I spent another couple of seconds in mental evasive strategy planning. Maybe I could schedule that colonoscopy the doctor's been bugging me about. You know, I might need another root canal at this time. I noticed the smile was fading. So I needed to say something, so I just calmly asked, can I just walk barefoot on hot coals instead of public speaking? She laughed. She didn't know I was serious. But determined I wasn't going down alone, I immediately volunteered David with Texas Sterling to co-present with me. So I said, to get the contractor's perspective, I quit. She agreed. Luckily, David agreed also when I let him know. And then here we are. A few constraints on the project. Medical Drive could not be closed. As I said, it's a primary medical route from 10 into the medical district. Had to have minimum one-lane open each direction at all times for emergency vehicle access to medical facilities. We had a couple of milestones on the project. Fredericksburg Road could only be closed about 14 days, maximum. Milestone 2, we expect the project to be completed in around 400 working days based on a 6-day work week. There's some ADT figures for you that were used for design. Liquid damages were set at $1,285 a day. Incentives were set at $15,000 per day for milestone 1, $5,000 per day for milestone 2. The maximum payment for milestone 1 was $75,000. Maximum payment for milestone 2 was $100,000. The original design, as I said, was for a conventional bridge, but using precast caps. This design, sliding the bridge, allowed it to be Fredericksburg closed fully for only 1 week, and then we reopened to traffic. The slide itself, to actually push the bridge into place, only took 1 weekend, working 24 hours a day, 2 crews. So it was around the clock, thank God for 5-hour energy. Here's a few stats. This is the first slide in Texas. It's been done in other states, but this is the first time it's been done in Texas. Each half of the bridge was slid 184 feet 9 inches. Each half of the bridge weighed 2,043,000 pounds. And that's just half the bridge. Okay? We think this is the longest slide in the U.S. based on the method that's employed that we use. And we think it's the heaviest in the U.S., again, based on this slide methodology we used. Okay? The bridge was constructed in 2 halves because obviously of weight considerations constraints. At this picture here, we're about halfway through the project. There's been a lot of work accomplished up to this point. A lot of utilities had to be moved. Medical drive was set on a different alignment, a new alignment, to bring it in to the intersection. We put in water, sanitary sewer, gas, telephone, a new storm drain system. The westbound and eastbound frontage roads have been constructed at this point. Again, that was to meet that constraint of not closing Medical Drive at any time. So we had to build frontage roads first so they can continue access through the intersection. The medical main lanes, as you can see, they've been excavated partially. Let me get this clicker right. Down here. This is to accommodate just building the bridge. This right here is the edge of Fredericksburg Road, running north and south. You're looking southward right now. The bridge was obviously constructed off alignment in the middle of the future main lanes of Medical Drive and then pushed into place. Next few slides show setting some beams and things. This is just to show most of the work is just like regular any other bridge. You're just building it off alignment. So, emphasize that most of the construction, similar to most bridge constructions, but the workspace was very confined. The total clear width was about 58 feet, I think.
Inside the abutments, yeah.
Inside the abutments. That's where you had to work. Plus here, the next few slides are cranes and beams in motion, what's not to like. So we are picking the second beam actually right here. You got 2 cranes, 2 crane pick. This first crane then swiveled around, the back crane walked forward with the beam. And then bring it on around. The back. That's the back crane back there. And this is the back abutment on the south side. You'll notice right here, the pad's already set. You know, this guy's not wearing a harness because he's sitting on the ground. So he's not having to work in the air. Little thing about safety. Of course, he's got to watch the equipment now. So here's the beam set in place. And there's the finished, all the beams have been set at that point. Medical Drive, westbound frontage road is right here, where the cars are coming at you. Okay. We set 38 beams, 2 different widths, and it took about 10 to 15 minutes per beam to set. Okay. Gotta get to my notes here. Okay, use that one. That's where we are now. Normal bridge construction. Again, there's some steel in place. And just a normal deck placement, concrete. Just like, almost like a real bridge. Going through. This went really smooth. We placed 294 cubic yards in that deck. Took it about 9 hours from start of placement to putting the blankets on the next morning. Okay. We used 2 pump trucks. Texas Sterling used 2 pump trucks. I just watched. Short the other end, a shorter one, because the span is so long. And actually, this is the width of the bridge, 184 feet. The span is 64.
Redundancy.
And then we also had redundancy of the pump trucks. Because it's my picture, I just think really large pump trucks are cool anyway. Here's a picture of the slide slab bridge abutment. You can see right here, if I quit pushing the wrong button, that is the Teflon pads under place. This is called a slide shoe. For each half of the bridge, there's 2 slide shoes on each abutment. Each slide shoe is 7 foot 4 inches long, 7 foot 6 inches long by 1 foot 4 inches wide. The bearing shoes, which are these things right here, these don't participate during the slide. They're elevated. These are just for final position when we lower the bridge into place on the final pads. This right here is called a slide slab. It's a, I had some measurements, 1 foot 2 inches thick by 1 foot 5 inches wide. It was cast 360 feet long for the full length of the bridge. Plus, you had to have where you construct a bridge and then where it's going to final set, so you had to cast the whole thing. It is set on top of drill shafts that later become a drill shaft retaining wall with panels and things. This close-up of one of the slide shoes and with the Teflon pad on it, on the pad. You'll notice that the ends are turned up. This is a steel plate, armor plate on the bottom of that slide shoe. Turn up the ends, they don't catch on the Teflon pad when we're shoving the bridge and tear the pad. We also require a lubricant and stuff. I know all of y'all know this, but I thought it was cool to learn that that bottom of that steel plate is not smooth. It has a brushed finish to it. The purpose of that is it has to hold that lubricant as we're sliding the bridge. That gives that lubricant some place to rest and catch in. If it wasn't, it was completely smooth, they would just sort of squish out when you lowered the bridge onto it, out from under that steel plate. Okay, and then you wouldn't have any lubricant and stuff. Okay. Did I mention the bridge? Half weighed 2,043,000 pounds. So that's a consideration. Here we are applying the special lubricant. Okay. This was one of the key features of most of the news people when they come talking about it. Is, you know, it doesn't matter, it's first slide in Texas, heaviest slide in the U.S. They were keying on that we use Dawn as a lubricant. Okay, so it's good stuff. Cleans your dishes, gets the crude oil off of your water file, and helps slide bridges. This is a central pump used for the hydraulic jacks. You had to have a central pump going to both sides to ensure uniform pressure. So we're sliding even. They had calculated a maximum pressure during the slide to use. It was about 7,500 psi, so we don't damage the bridge and push too much against it. We almost reached that when we first started the first half. I think we got up to 7,400 psi, something like that. At what point, right then the bridge lurched forward about 18 inches. Okay, that was exciting. For 2 million pounds in motion all on its own without us controlling it. Okay, but then everything caught up and we did okay. We used about 800, 700, 800 psi was all we needed to slide the bridge the rest of the way. The other half. Here we are getting ready to hook up the horizontal jacks for the first half. Use a 100-ton jacks to slide each bridge half, one on each abutment. We're going to have a short video when David gets done with his presentation to kind of show the operation. It's just a couple of minutes. Here's a picture of the hydraulic jack up close. They're cleaning the port where the hydraulic hose connects up. That's got to be really, really clean. They use brake fluid cleaner to clean it. Again, to ensure everything pressures the jacks, you don't have any contaminants in there that will stop that up. Here's a picture of the anchor block. This is the downstream on the east end. The duodag bars went through there and through the abutments. They were locked in. That's what the jacks pushed against, that bar, as we slid the bridge. This was exciting when I first saw it. I had some questions. Of course, David said, everything's fine. It's okay. Don't worry about it. But that steel anchor, the bottom part of it, the studs are anchored up into the concrete, and this is monolithically poured with the rest of the bridge cap, bridge abutment. The slide slab is not perfectly smooth and level. It's got a little bit of irregularity to it, and because of the weight, that gets very pronounced as that bridge sort of wobbles a little bit, kind of wiggles down, creates point pressures at those corners, and it was popping those corners off with those slide shoes. But again, it wasn't critical to the bridge itself, holding the bridge up and all that when we get in final position, and we later just took that off and patched it with high-strength grout. The bridge also didn't want to walk just perfectly straight down the slide slabs. It kind of wanted to move laterally back and forth. So they used a small dozer to put a little bit of lateral pressure against that one side to help keep that bridge sliding more or less down the center of the slide slab and not let it walk over. Because if it walked too far, it would start dragging on the back wall. We're complete here at the slide. Both halves are in place in Fredericksburg Road. Here is the other anchor block at the other end.
Yeah. Point out that that's the backup block because I didn't have a good picture.
Okay. The other part was unique was that this anchor block on the west end, the back block, that enabled us to have a reverse capability. That's not usually done. But we needed, just in case Mr. Murphy showed up, they gave us some options in case we needed to back the bridge up a little bit. Okay. And again, right here, slide slab, and here are the drill shafts that later became the drill shaft retaining wall when we finished the excavation. Here's a picture of the completed bridge. Drill shaft retaining walls, everything's nice and painted. We're looking west towards the medical district. David?
You want me to go or do you want to show the video?
No, we'll show the video then. Yeah. We'll show the video when you're done.
Go.
You want to use this? You want to talk about it?
If you can get it off real quick. Is that easy? Sweet. Thank you. I did a lot of research during this process, and again prior to this meeting, to on all the other accelerated bridge construction methods. But I don't think I'm gonna have time to go through that stuff. So I'll just try to flip through that real quick and then get to the important stuff. Do I just keep clicking, or do I need? That's back on yours.
Oh. Minimize that one and pull up yours.
There we go. Okay. First, I had to represent. So, as y'all know, probably most people here know, A&M. It's notably the best school in Texas, but okay, that's the picture of the bridge slab before we started sliding it. And one thing I do want to point out, one of the last pictures Lonnie showed was the backup blocks. Those backup blocks became very, very critical to the success of the project. Not because we had to back it up, by the way. Just real quick bio, Texas Sterling, David Griffin, class 2002 construction science, Fred Med project. Lonnie went through that stuff. $14 million contract. Multiple types of ABC methods, accelerated bridge construction methods, foundation and wall elements, rapid embankment construction, prefabricated bridge elements and systems, structural placement methods, fast track concrete, and that's the website. If anybody's interested, it takes you to the manual. It's about a 300-page manual. Be good for a deer stand or something. And that's cool little picture. We talk about it more. And again, I'm not going to go through these, but these are different. I just want to point out that, as most of y'all probably know, there's multiple types of accelerated bridge construction methods, or accelerated construction methods. And then that one's pretty cool, I thought. Like standard polyester, geofoam, and then preloading with wickers and vacuum, rock piers. That's the column supported embankment technique. It's this I do want to stop on, prefabricated elements. We actually did one of these in San Antonio as well for TxDOT through the county, Bexar County. We did precast caps, and actually pre-tension precast caps. From what I understand, the first that TxDOT's allowed or issued drawings, or TxDOT standard drawings, if you will. They kind of had to expedite them for this project. We set 36 of them, 18 in 3 days. It was more like 2 and 14 in 1 day. But that's some pictures anyways. Just other methods of accelerated bridge construction methods. Y'all probably all heard of this one. The SPMTs, and then that's a launch, a bridge launch, which has been around for a while. And then horizontal skidding or sliding, that's what we did. Those are just 2 pictures from other parts of the country. Now, one thing I pointed out, besides being the first lateral bridge site in Texas, what is unique about the Fred Med Bridge? And it's, hint, see below, that's not our bridge, by the way, it's somebody else's. That's more of a standard application up in Utah or Oregon. And then that's ours. And Lonnie kind of gave it away earlier, but the difference is, how do you do that little button? Yeah, traditional, Fred Med. We're building on existing substructure. I say existing, we installed it, but the reason the engineer brought it to me in the first place is because he said, man, Texas has got so many drill shaft retaining walls, it's crazy. He goes, I mean, you could do this all over the state. And it's a perfect scenario because typically they're temporary structures, and it gets expensive. And it's also riskier. So drilling across Fred Med, just problems. One, at the beginning we had to decide between drill and backfill with rock and asphalt, like the plans called for. It's actually supposed to be a type of ABC, but we turned it into a bridge slide. And the plans indicated they drill across Fred Road and backfill with rock and then put asphalt in. And we just thought that it prohibited us from being able to access the work site. So we made a big decision. It worked out in our best interest. We trenched across the whole thing, in one night and used trench boxes. Now, the trench boxes gave us a few problems, and one is that we wanted to keep it open. We had to maintain plates, and those plates aren't cheap. They're not cheap to rent. They're not cheap to buy across the road. I'm sure TxDOT really doesn't prefer that, but it, like I said, provided everybody access to inspect the work and do the work. Another problem with trench boxes, we had to redesign the back wall to take into account the spreader bars. Another thing, we had to move them around a lot to be able to drill in the right location. The length of the bridge slab caused some problems. One is, I'm not an engineer, by the way, construction science, so I might say stretch, you might say elongations, et cetera, deformation, something. Anyways, stretching those 2 million pound, trying to pull a 2 million pound structure, we had Dewey dag bars and stretched out about 200 feet, probably 200 plus, because you had to go through the backup block and or through the anchor block. Anyways, when you stretch that much weight that far, even though those bars are designed for that, when you have a 10-inch stroke jack, we could only move it about 2 inches. We literally would stretch those Dewey dags that far every time. And that little metal thing right there was our coupling lock, so we could actually hold the tension on the Dewey dag bar, but we kept having problems and losing tension. Unfortunately, being the proactive project manager that I am, I ordered twice as many couplings as we needed, and thank God, because we had to wind up cutting Dewey dag bars, and I think we used our very last coupling. Other problems. I know this was probably talking about the anchor block, the backup block, like Lonnie pointed out. We wound up discovering, and the engineer that designed this, he's designed a lot for our sister company, RLW in Utah, and he had never experienced this before. For some reason, the initial to get the bridge going, the initial, whatever it is, Lonnie, you're the engineer. Anyways, it was just a tremendous amount of pressure, and after we got moving, like 600 to 800 psi. But if we wouldn't have figured out a way around the stretching of the Dewey Dag bars, we would have been in trouble. It probably taken us 2 weeks to slide the bridge. But at the beginning, we had to make another big decision. And our sister company, Utah, usually doesn't use backup blocks because they've done so many of them, they just don't need them. It's a waste of money. They just hook a big tractor up to it and pull it, or hook a big excavator up to it. And we're like, he said it in front of TxDOT, and they kind of looked at us funny. Anyways, so I said, well, I'm going to take the backup block. Give me that option, thanks. And what it wound up doing for us, we could actually pre-tension the Dewey Dag bars and then just run the plunger jacks up and down the Dewey Dag bars. And the engineer had never thought about that. Nobody had ever used it, and it wound up being a beautiful thing. Saved us a lot of time, too. I mean, we literally slid one in, I think, 8 hours. And that's most of the problems in that was the control problems. Keeping them in a 2 million pounds on Dawn dish soap just doesn't slide straight. That's the big block. That's the front block. Lonnie showed the backup block. Again, yeah. Saturday, Whoop 2002. I'll be there. Look for me. Why? Honestly, I don't know. I was here. I was part of a big part of the decision. I was actually reluctant to do it first, but my boss wanted to do it. So I embraced it and ran with it. It was a great experience for me and a great experience for the company and TxDOT. And we worked together in TxDOT San Antonio district, great district to work with. And I thank them all the time for signing that change order and and for letting us do it. Anyways, we do it off in the West, Midwest, Utah, different states around Nevada. And honestly, we want to bring it to Texas. We think that we can, if it starts getting implemented, we can lead in the construction. That's a YouTube video we're not going to watch. Just standard method. Usually bridge slides are used in a rural setting where it's like 2 lanes, and it's a farm road. You got to detour 45 miles if you tear that bridge out, and also you'd have to set up flaggers one way with a controlled environment because you only got 1 lane going each way. So it's used a lot in rural applications, and that video is showing that. So usually the bridge is like 40 feet wide, not 185 feet wide. And these are just notes I've made. We've gone through all that stuff, really. Just and some other pictures. Let me scan through these. Lessons learned. The back of the abutment, it wasn't where we had Lonnie had a picture earlier where we had the plate and the coupling and the Dewey Dag bar coming through it. That's not the picture, by the way. It wasn't exactly flat, if you will. It had a slight angle, and we'd actually adjusted that some, but apparently we didn't adjust it enough. We think that contributed to the control problems. So your pressure point, of course, needs to be flat, and preferably a plate too. That was a big lesson that we didn't choose right on that one, but we chose close to being right. I talked about sleeves. Grade, perfect, because of what Lonnie said. Just different pictures, some cool pictures. It's a flow fill wall, actually, to assist us in being able to build the thing and keep traffic up there at one point. That's a shift change. At any given time, we had at least 16 guys, And every shift change we would do, meet as a group and personally assign positions and what the next guy taking his place was going to do. TxDOT was involved in this as well. They didn't speak unless I don't know if y'all ever spoke.
No.
Okay. But, I mean, anyways, we did, nobody got injured, nobody got hurt. When the thing lunged 18 inches that felt like 6 feet, it scared the bejesus out of me. I was about 3 feet away from the abutment when it happened. There's Mr. TxDOT himself, Lonnie.
Move on.
And that is our engineered, calculated method of steering a 2 million pound bridge structure right there. Everything is calculated. The dirt, the embankment underneath the dozer, the weight, even the weight of the man operating the dozer is taken into account. And that's after we put it together. If you look up, you'll see lights. That's in the middle of the intersection. And that's it.
All right, we got time for the video?
We're over already, I guess, but
No,
I'm not the boss, so.
Okay.
Show it? I don't know. How do we get to that? Is it in your
Yeah.
deal?
Come back, just minimize that picture. Yeah, this deal.
Oh, this one?
Yeah. And then, yeah, here's
This
the
one?
time lapse. Just show the time lapse.
Okay, now, this took 8 days, by the way, so the time lapse, you'll see, I can try to walk you through this. I think there's probably about 10 hours throughout the week I wasn't there because I was sleeping, but I'll try my best. Anyways, this is probably Friday morning, like at 1 in the morning or so, shut the intersection down, and of course put barrier up, traffic control. In hindsight, I sure wish I had a bigger piece of iron sitting there. We were going to do this, and then it rained on us, and some bad weather. And if we'd have got to do this in the dry, you're about to experience the epitome of poor mishandling of dirt. If it wouldn't have rained on us, and rained a lot, we wouldn't have had to do that. But we got a pretty absorbent amount of rain, and it caused us to have to. It was one of the major contributing factor in having to handle dirt 3-4 times. But anyways, you can see we're having to drop the elevation of the dirt. We did it with a big equipment. They have to come back, and I don't remember why we didn't get it right the first time, because we always do. But one of the things I thought was kind of important was you can barely see it, but there's a cyclone fence on top of that barrier. And I'll tell you what, it kept a lot of people out. I mean, we literally had to run people off the bridge that went around the fence. And one of them was riding the bridge.
Yeah.
Or so he says. I mean, we weren't pushing it while he was on it, but.
We had police on site. They were monitoring traffic and stuff during the slide, but
Here it goes.
it's fixing to move. But one of the policemen that was up on top told us later that he had run off a guy twice to try to jump on that bridge and stay on it while it was moving. The guy kept saying, "I'm with the press." The cop said, "I don't care. I won't put you in jail. You don't get off the bridge." So that was fun.
I would like to. Now you saw the picture of the dozer, but I didn't have a picture of the or other calculated engineered steering mechanism. Unfortunately, we couldn't get that traco underneath the first section of the bridge to control the second one. So that traco is actually our steering mechanism. And I mean, I was actually for excavating even further down to get that traco to the next section, but my general superintendent wasn't having it. He thought the dozer was fine. You can see the spaces, the gaps, blockouts in the back wall. We come back and pour those later. Actually, something else unique about this is, and this is, we put it together. We started October 31st, And I think we slid November 1st and 2nd. We slid, took us 2 days, a Saturday and a Sunday. We started early Saturday morning and finished Sunday evening, Sunday night. And then, Lonnie might get mad at me for saying this, but we could have opened this thing a lot sooner, but we didn't have any incentive to as a contractor. Just saying. Yeah. Maximum bonus, of 75,000, and that was 8 days of work. So it took us 8 days.
Okay.
Okay.
All right, I think we're being shoved off.
Yeah, we're being shut off, but we utilize it. Yeah.
Thank you.